Welcome to Easy BTech, your guide for BTech and beyond. My name is G. Sampath. I am going to explain the subject VLSI design. Today we are going to discuss the switch logic and alternative gate circuit. Let us see what is a switch logic and what is the disadvantage by using this switch logic and what is the alternative gate circuit. Right, first let us see the switch logic. What is a switch logic in MOS transistor in IC based circuits? What is a switch logic? Right, let us see this one. In this switch logic is based on switch logic is based on pass transistors and transmission gates right, pass transistors and transmission gates. So based on this, the logic signal passing through pass transistors, and another one is transmission gate. Let us see what is a pass transistor and what is a transmission gate. So in this approach, in this switch logic approach, in this approach, so the signal logic through switch logic in this approach it is fast. In this approach it is fast and less power dissipation. So by using this approach, so through these pass transistors, based on pass transistor and transmission gate, by using this, it is a fast. In this approach, it is a fast and low power dissipation. Right? Low power dissipation. It is a low power dissipation. So no static current through supply. No static current through supply. There is no static current flow through the supply. No static current through supply. Right? This is a advantage of by using this switch logic. Less power dissipation, faster a signal. The logic flows through this switch logic. It is fast and low power dissipation and static current through supply rates. So let us see some of the properties of pass transistor and transmission gate. Some of properties of pass transistor and transmission gate. Right? Well, let us see this one. Some of the properties of pass transistor and transmission gate. Now when the logic is passing through a pass transistor, first one, pass transistor. Let us see the first one, pass transistor. Right, let us see Nmos and Pmos. Pass transistor means just it is act as a switch or relay, the signal passing through by effective gate voltage is applied. So it is Nmos pass transistor. It passes the logic. When we are applying logic over here, you see this one. You are applying logic 1. Okay, we are applying logic 1 from here to here. So applying logic 1 here, we are applying, let us say it is X is equal to plus 5 volts VDD, right? Plus 5 volts we are applying. Now output of this one, it is Nmos transistor. This is Nmos pass transistor, right? Nmos pass transistor, Nmos pass transistor. So when 0 to 1 logic is applied, then what happens? Then output through this is degraded because of the threshold voltage. Because of the threshold voltage, the logic level signal is reduced. So 0 to 5 volts. Then we get here. We get 1 volt threshold voltage. Then we will get here this more. So it is up to 4 volts we got. You see the 4 volts level signal. The pass transistor, Nmos pass transistor, when input logic is applied, gate voltage is 5 volts is applied, then there is a path established from here to here. There is a path established from here to here. Okay, path established. It is on like a switch. When external gate voltage is 5 volts, then this is a gate, source and drain. So the path established from here to here, gate voltage is applied, positive 5 volts is applied, then it will be on. When logic is passing through source to drain, then what happens? The logic, it is reduced. You see this one, 0 to 4 volts, it is reduced. So logic 1 reduced. You can say it is logic 1 degraded by logic 1 degraded by threshold voltage VT. Threshold voltage, due to the threshold voltage between source and drain, so it is threshold voltage required, then logic 1 is degraded, right? Threshold, due to threshold voltage VT. Okay, so this is about a pass transistor of Nmos. And now see the Pmos transistor. Let us see the Pmos transistor. From here to here. If you see what happens a logic through this one. In a Pmos transistor, the input voltage we are applying again 0 to 1, logic 1. Now, so bubble across the gate terminal. So X is equal to, X complement is equal to 0 volts we are applying, right? X is equal to X complement 0 or logic 0. 0 volts or logic 0 we are applying to gate with respect to source to drain. It is a Pmos transistor. Pmos transistor. It is a Pmos transistor. By applying Pmos transistor, what happens? The logic 1 is applied. So this is a Vin. Vin is applied through source and drain. So external gate voltage is 0 volts is applied. There is a path established from source to drain. There is a path established from source to drain. Path established, right? Path established. Now the output is, you see this one, reduce the logic level, 0 logic level. You see it is a 0 logic level. The 0 logic level is reduced. You see this is a 0 logic level. Okay, this is a 0 volts and 1 volt, and this is a 5 volts. Due to the threshold voltage, this portion is a logic 0 level. So logic 0 is degraded by threshold voltage. So here logic 0, so it is a logic 0. So logic 0 degraded by threshold voltage Vt. Threshold voltage Vt. So in these two cases, the switch, it acts as a switch when external gate voltage 0, when external gate voltage is 1. So the switch, it acts as a switch, MOS transistor act as a switch, the logic is applied through source and drain. So when one is applied, so the one, logic 1, logic 1 level, it is logic 1 level. This is a logic 1 level. This is a 0 level. Then output is 0, 1 level is degraded by threshold voltage. Now we are applying logic 1 through source and drain. External gate voltage 0 voltage is applied. Logic 0 level is degraded by threshold voltage Vt. Right? So it is a threshold voltage -1 and +1 for Nmos transistor. Right? And also, if you see another one, due to the pass transistor, the threshold threshold voltage affected through the source and drain. Right, output of this one, let me see this one. If x is equal to VDD, we are applying. If you are applying VDD, okay, here logic 1 is applying, right? Logic 1 we are applying. Then the output of this one is due to the threshold voltage. So the voltage logic 1 is VDD minus Vt, threshold voltage, or we can say VTP, pass transistor threshold voltage. Now output of this one as a gate voltage to the another transistor, another Nmos transistor. Here again we are applying logic 1. Right, here we are applying again logic 1 we are applying. So what happens, the output of this second pass transistor, so this is transistor 1 and the transistor 2, transistor 1 and transistor 2. What happens, the output over here VDD minus 2 VTP, right? Pass transistor threshold voltage of second transistor. So when VDD is equal to 5 volts, we are applying, then there is a path established from source to drain, right? This is a gate terminal, source terminal and drain terminal. Again, this is a gate terminal, source terminal and drain terminal. The logic is passing through source and drain. When gate voltage VDD, there is a path established, then we can send the signal. The logic sent through the source and drain, then output of this one is VDD minus VTP. Because of the threshold voltage is affected, then VDD minus VTP. Then output of this again is given to the gate of the second transistor, then it will be on the path established from source to drain, right? Due to threshold voltage, now the logic 1 is equal to this VDD minus second transistor threshold voltage. So on we are connected the signal passing through. What happens, due to the threshold voltage, the logic level is degraded, right? How much it will be as per this threshold voltage? So 1 volt for Nmos minus 1 volt for Pmos, right? Let us see the transmission gate. Second one is transmission gate. So there is a property of Nmos transistor or pass transistor Nmos and Pmos. Now let us see the transmission gate. Right? We are seeing that the logic is passing through source and drain. In pass transistor, it is degraded by threshold voltage. Okay, it is degraded by threshold voltage. Now what happens in transmission gate? The transmission gate is defined by and it is designed by both Nmos and Pmos. Right? That is called, it is a transmission gate. So transmission gate is nothing but it is designed by both transistors, Pmos and Nmos. It is a circuit symbol, right? X is equal to, we are applying 5 volts, right? Here X complement is equal to, we are applying 0 volts. Now V in we are applying, and V out will be taken. So transmission gate designed by Nmos. The upper one is a Nmos transistor, Nmos and lower one is a PMOS transistor and PMOS transistor. It is designed by both transistors, Nmos and PMOS transistors, right? PMOS transistors. So what happens then if you are applying without degradation of logic level, then we will get a output signal without degradation of threshold voltage, then as it is we'll get the output signal. If you are applying logic 1, then output voltage also 0 to 1. So without degradation by threshold voltage. So without without degradation without degradation will get signal output. Without degradation will get signal output. Right, same output, signal output. We can say it is a V in is equal to V out. V in is equal to V out. So no threshold voltage effect. Can say no threshold voltage effect. No threshold voltage effect. No threshold voltage effect in transmission gate. No threshold VT effect. No threshold voltage effect. So it is designed by both Nmos and Pmos. We are applying logic 1, we are getting logic 1. So it is both transistors are on, the signal is passing through. So no threshold voltage effect in this transmission gate. This one is a property of the transmission gate. Okay, let us see the symbol representation. If you see, this is a symbol representation. In a symbol representation, we represent like this. Okay, right. Let us see this one. It is a symbol representation, right? This one is a symbol representation. Yeah, this is a symbol representation, right? Okay, now this is a symbol representation of a transmission gate. So this is a bubble representation. X is equal to plus 5 volts we are applying. X complement is equal to 0 volts we are applying. Now, so we can say it is V in and V out. V in and V out of pass transistor symbol. Pass transmission gate symbol. It is a transmission gate symbol. Right? A transmission gate symbol. Transmission gate symbol. Right? Then the previous one is a circuit transistor representation. It is a transistors. Transmission gate designed by transistor design. It is a transistor design. Right? Transistor design. So there is a symbol representation, gate level representation. Let us see some of the switch logic. Right? Some of the switch logic. So it is a small number of arrays are connected. Some of the switch logic, arrays of transistors are connected. Right? Let us see this one. For example, the arrays of Nmos transistors, pass transistors. Switch logic is based on two. Right? One is a pass transistor, second one is a transmission gate. So V in we are applying. You can take it is the output signal. So it is a pass transistor. So A, B, and C. So when A is equal to, B is equal to, C is equal to 1. So gate voltage is 1. What happens? There is a path established from gate. You can say it will be source and drain, or drain and source. Right? We can interchange, no problem. Source and drain. The signal passing through. when gate voltage is effective gate voltage, A is equal to 1, B is equal to 1, C is equal to 1. Effective gate voltage positive, NMOS pass transistor it is. NMOS pass transistor passing through the logic when logic gate voltage is applied. Nmos pass transistor it is. Nmos pass transistor. So it is act as a relay circuit. The signal input and output flows through this when the gate is open and close, on off the switch, then signal flow through this. It is called as a relay. Now in this switch logic, the pass transistors, when gate voltage is equal to 1, there is a path established, right? It is a closed switch, right? It is a closed switch. You can say it is a closed switch. It is a closed switch, signal passing through. So V in is equal to V out. So V in is equal to V out. V in is equal to V out. So it is degraded by V in is equal to V out, degraded by threshold voltage. Signal passing through this, what happens in a pass transistor property? Then whatever, then there is a threshold voltage affected. It is degraded by threshold voltage Vt, degraded by threshold voltage Vt, right? So in a pass transistors, the signal passing through when effective gate voltage is 1 is applied, it will be on, 0 is off. So 1 is applied, there is a path established from source to drain. We can send a logic from here to here, right? We can send a logic from here to the output signal. So we will get the output by degraded signal. Output is degraded signal. It is logic 1 level will be degraded. Logic 1 level will be degraded as we are seeing, right? It is a 5 volts. Now we get the only 4 volts. 4 volts because of the threshold voltage, 1 volt is drop. 1 volt is drop. It is because more than series connected. So 1, 2, 3 transistor series connected. Here VTP, my 2 VTP, 3 VTP, like the threshold voltage is drop over here. Okay, this is a NMOS pass transistor. Let us see the another one is you can connect a transmission gate. Let us take some transmission gate, right? Let us take some transmission gate connected in parallel. Connected in parallel. Well, transmission gate is designed by both Nmos and Pmos. Both Nmos and Pmos. Both Nmos and Pmos. Okay, we are applying a input voltage here, right? We are applying a input voltage here, right? We can say, so the output of this one, the output of this one, the output of this one, right? Here we are applying V1, V2, V3. There is a parallel connection of this one, parallel connection of transmission gate, right? We are applying A, B, C, A, B, C. So it is A complement, B complement, and C complement. So V out is equal to, output of this one is equal to parallel combination. So we can say V1 into A plus V2 into B plus V3 into C, right? Is a parallel, the signal passing through this one is a parallel combinations, right? A parallel combination V1 plus V2 plus V3, right? Without degradation of, it is without degradation by without degradation of threshold voltage Vt, right? Threshold voltage Vt, here the previous one, so it is degraded by threshold voltage Vt, and here without degradation of the threshold voltage, right? If you see the parallel combination, let us see the parallel combination. It is a transmission gate. It is a transmission gate. right? Transmission gate. Now let us see this one, some parallel combination of parallel combination of MOS transistors, parallel combination of MOS transistors, right? Let us see this one, parallel combination of MOS transistors, Nmos transistors. These three are in parallel. These three are in parallel, where we are applying VDD, VDD, and if you take the sum of Nmos transistor in series, Nmos transistor in series, so it is a three input. It is a three input OR gate, three input OR gate. You can say this is output voltage. Output voltage VDD passing through this one. Effective gate voltage is A, B, and C. A, B, and C. Here also, if you are applying A complement, B complement, and C complement, so it is NMOS, three input, three input, three input OR gate, three input OR gate, right? Three input OR gate. So Vout is equal to, then Vout is equal to what happens? A plus B plus C, right? A plus B plus C. So ABC is equal to ABC is equal to ABC is equal to 1. Now A complement, B complement, A complement, B complement, C complement is equal to 0. So it is act as a OR gate, right? So A is equal to 1, B is equal to 1, C is equal to 1. So the complement is 0. A complement 0, B complement 0, C complement 0. Now VDD passing through, then so it will, this will be on, this will be on, this will be on. VDD passing through, then Vout equal to 1, Vout equal to 1. So it is a parallel combination. So it is also affected by threshold voltage. So output affected by affected by threshold voltage, affected by threshold voltage, right? Affected by threshold voltage, VT. So whether it will be series or parallel, it will be affected by threshold voltage, but not happened in transmission gate, not affected. But the disadvantage of this one, of the switch logic, so disadvantage of the switch logic, only one disadvantage of the switch logic is switch logic is in pass transistor, threshold voltage affected. In pass transistor, VT threshold, VT affected, right? VT affected. The second one, in transmission gate, in transmission gate, so not affected VT, but area is more, not affected VT, but area is more area required, but area is more. So that's why we go for the alternative circuit. Due to the pass transistor, there is a threshold voltage affected, right? The another one is by using the transmission gate, the signal passing V in is equal to V out without affected by threshold voltage, but more area is there, more area occupies. So it is not possible when the signal passing through the output logic without degraded logic. So without degraded logic, we are using the alternative gate circuits, alternate gate circuits, right? What is the alternative gate circuits? by using a switch logic, transmission gate and the pass transistors, threshold voltage affected, another transmission gate is area is more. We go for the alternative gate circuit is the basic gate by using the basic gates. So by using the basic gates, right? So restore the logics. So gate restoration, restore the logic, restore the logic which is affected by threshold voltage, which is affected by threshold voltage, right? Which is affected by threshold voltage, affected by threshold voltage. So restore the logic which is affected by threshold voltage by using not gate, not gate, inverter. So not gate or inverter in between them, inverter, right? Inverter. So inverter is a basic gate which is used to restore the logic. So inverter is inverter. When I am discussing inverter, the inverter, there I discussed what is the inverter. So inverter is a basic gate which is used to restore the logic. Inverter is basic gate. Inverter is basic gate. The alternative gate for the threshold voltage effect of threshold voltage, the logic passing through the switches means MOS transistors. Inverter is basic gate used to restore the logic, right? Restore the logic, restore the logic. You see this one. So let us see this one. Let us see this one. The pass transistors are here. The pass transistors are here. The signal is applied through pass transistors. We can connect the inverter, right? Here we are connecting the inverter. Here we can connect the inverter. Then again we are using small number of arrays. The small number of arrays we are using, right? Small number of arrays, series connections, right? If you are using the two inverters, it can be restore the logic. You see how it will be restore the logic. You see this one. So V in we are applying. This is 0 and 1. A, B and C. So inverter 1 and this is inverter 2. Inverter 2. D, E, F. Right? What happens here? V in is equal to 1. Passing through this, it will be degraded. So inverter 1 output is it is 0. Then 0 passing through this, it will be degraded again. Then output of inverter is again 1. You see this one. It is restored the logic. It will be restored the logic when it will be connected to through the pass transistors. Connected to the pass transistor. Restore the logic by using the inverter 1. By using this inverter, you see, by using this inverter 1 and inverter 2, restore the logic. So by using, you can say, by using inverters between them, inverter between pass transistors, restore the logic, you see the basic inverter, right? So by using this, so it is a AND logic and it is a NOT logic. So and NOT is the basic one, basic gate. We can design also, we can design so restore the logic of restore the logic by using NAND gate and NOR gate. NAND gate and NOR gate. NAND gate and NOR gate. NAND gate is series connection. So NAND is a series connection. NAND is series connection. Nmos series connection. Nmos or series connection. NOR gate is parallel. Okay, parallel, Nmos parallel connection. Nmos series or parallel before we are seen in a pass transistor. VT, threshold voltage is affected. But by using NAND means it is by and not, and not, right? And not. It is a NAND gate, right? It is a NAND gate. It is A B complement. If you are applying A and B, it is a NAND gate. NAND gate. NOR gate is a OR and not complement. OR and not complement. OR and not complement. Right? It is A plus B complement. NOR gate. So we already discussed this. Inverter by using the basic inverter, right? How can you design an AND gate in NMOS design? You can see this one. So one is a depletion mode transistor, another one is a series transistors. So A and B, output of this one is AB complement. By using this NAND and NOR, the restore the logic levels. So it is NMOS NAND, right? We already discussed NMOS NAND NOR gates, right? So when the logic is passing through this series and parallel transistor, VT, due to the VT threshold voltage, it is degraded. So it is recovered by using these gates, basic gates. One is inverter and NAND and NOR. Okay, these are the alternative gates. Alternative gates, right? Alternative gate circuits are, let me write here. So alternative gates are not gate, okay, and NAND gate, and the final one is NOR gate. So by using this, so we can restore the logic, restore restore the logic, right? So this is a alternative gate circuits of switch logic, right? Thank you. Please subscribe our channel, like, inform to your friends. So learn the subject more and very easily. Thank you.